Welcome to the final video in the 3-6 video series. In this video, we aren't going to look at a characteristic that is unique specifically to one function or another, but we are going to look at a characteristic that is kind of unique in its own way, that it's kind of separate from all the other characteristics that we've looked at so far. The characteristic that we're going to be looking at in this video is whether we are going to classify a function as even, odd, or neither. And even, odd, neither is going to revolve entirely around the symmetry of the function. Remember, symmetry is where if you folded it across that point, then both sides would form a perfect mirror image. So even functions are going to have symmetry about the y-axis. If we were to fold the function over the y-axis, it would match each other perfectly, and we can see that illustrated by these two examples on top. If we have an odd function, it's going to be symmetric about the origin. Now this is a little bit tougher to see and visualize because you don't flip it directly. It kind of involves two flips. You have to flip it once over the x-axis and once over the y-axis. But you will see that the values will match. We have x, y here, and we're going to have opposite values over here, negative x and negative y. So when we flip over the origin, all our x values are going to become negative and so are all the y values, and the two should match up. Now, if it doesn't meet either of these circumstances, if it's not symmetric about the y-axis or the origin, then we're going to say it's neither. Even if it has symmetry around something else, like a separate line, like y equals 3 or x equals 4, we're going to classify it as neither, even and odd, or as specific as we're going to get. Now, we do have an algebraic way to classify these, and we do have a test to determine whether a function is even, odd, or neither. What that test will involve is replacing an x with a negative x and comparing the result to the original function. So for example, if we were to plug in negative x into a function and we were to simplify it, get rid of all the simplification that we could, and we ended up with the same equation that we started with when we plugged in a positive x, we're going to say the function is going to be even. Now, if we were to plug in negative x and we were to get the complete opposite of the function when we did all the simplification, every single term was the opposite. If it was negative, it became positive. If it was positive, it became negative. Then our function is going to be odd. Finally, if we plug in negative x and we don't get the original function and we don't get the exact opposite, we just get something different, then our function is going to be neither. Now, there is a way that if you're getting lost plugging in the negative x's, you can try plugging in 2 and negative 2. Sometimes it's easier to deal with concrete numbers. There will be a rare situation where it might test incorrectly just because it was a fluky type of problem. You're not going to run into that fluke if you stick with a negative x, but if you're having trouble plugging in the x's to determine whether it's even or odd or neither, I did make a supplemental video that you can check out where it does illustrate this example plugging in 2 and negative 2, so you can kind of see how that works as well. But we would prefer for your main method to be plugging in the negative x. So as with a lot of these characteristics, we do have some patterns that we're going to look at. Now, our linear is the most varied. It may sometimes be even. Now, the only time that it's going to be even is if you get a horizontal line that's of the form f of x is equal to b. So that is going to be a horizontal line that can be folded over the y-axis. Now, it sometimes might be odd. Now, it can only be odd if it goes through the origin, and it's going to be of the form f of x is equal to mx. So in other words, your y-intercept has to be 0, and it has to go through the origin. And then any other situation that you're going to run into, if it's not in that form f of x equals b or f of x equals mx, then it's going to be neither. For a quadratic, sometimes it will be even, sometimes it will be neither. You just will have to kind of determine where that axis of symmetry is. And then finally, the easy one, exponential, will always be neither. An exponential function can never be even, and it can never be odd. So let's go ahead and just jump in and look at figuring this out algebraically. So if we are looking at example 4, we want to test whether this is even, odd, or neither. So what we're going to do is we're going to replace the x with a negative x. And everywhere we see that x, we're going to plug in the negative x value. So when we do this, we're going to simplify. And when we do that, we're going to take negative x and square it. Now, anytime that we square something, it's multiplying it by itself. So we are taking negative x times negative x. So anytime we have a negative times a negative, that is going to give us a positive. So that becomes a positive x squared. So then when we simplify this, this is going to be negative 3x squared, which is exactly what we started with. So this function is going to be even. For the next example, we have f of x is equal to negative 3x. We're going to, again, plug in negative x in everywhere we see an x. So we're going to have negative 3 times negative x. We're going to simplify it as much as we can. A negative 3 times a negative x, a negative times a negative is going to give us a positive. And when we multiply 3 times x, we're going to get 3x. If you look, that is going to be the exact opposite of negative 3x. So we did find that f of negative x is equal to the opposite of f of x. So this is going to be an odd function. Finally, our last example, we're going to see it's an exponential. So we don't even have to plug anything in. If we remember our rules, we can go ahead and put neither. However, if you were to not remember that and you did need to go ahead and test it, we can go ahead and show that. F of negative x would be equal to negative 3 times 2 raised to the negative x power now. So remember our exponent rules, that anytime we have a negative exponent, it's going to flip that number to the bottom and the exponent will become positive. So this would be negative 3 over 2x. That is not the opposite of f of x, and it is not our original f of x. So we have confirmed our answer of neither. Alright, if you do want to check out the 2 negative 2 method, I will post a supplemental video that follows these examples using that method. But for now, go ahead and give the U-Tries an attempt with this method. Come back, check your answers, and then get started on the practice and prepare for that mastery check.